Okay, this will be a really short video. We won't have to do any more deriving like we've done. All these values can be found already computed and in tables. The xi's and the ci's can be found in tables. In your textbook, I think it's table 5.1, and you might need that for a homework problem. So the arguments for the 3-point rule would mean there are 6 unknowns. There are 3 ci's, C1, C2, C3, and X1, X2, X3. And the table specifically shows integrals with the limits of integration from -1 to 1. And I'll make a comment about that again later. But we're summing through 3 things. Each one of them has 2 unknowns. C1, this is C1 f of x1 plus C2 f of x2 plus C3 f of x3. And from the table, you can get the following. C1 is 0.556. C2 is 0.8889. C3 is 0.556. I left one out here. These are truncated values. They're not exact. And then x1, x2, and x3 are going to be numbers between -1 and 1. x1 is 0.7746. x2 is 0. And x3 is, let me check one thing real quick. X3 is, this first one is negative. Then x2 is 0, and x1 and x3 have the same absolute value. And again, these are approximations. If you plug them into the formulas, you get exactly 5/8 on that, and 8/9 on that one. And then these two as fractions are negative radical 3/5 and positive radical 3/5. And then of course that one's just 0. Now the textbook calls these, the CI's, the weights. And it calls the x's the nodes. That's the points on the x-axis that fall between the limits of integration a and b, but in this case between -1 and 1. Oh, one more thing. For the 3-point rule in the text, it's n equal 2. So if you want the 4-point rule, you'll have n equal 3. 5-point rule, you'll have n equal 4.